Hey there, Prof. Aram here, and in this video, I'm going to go over some of the important time value money relationships when it comes to discounting or finding present values. So let's get to it. The first important relationship is that for a given interest rate, the longer the time period, the lower the present value. So here in this graph, we are seeing the present value of $1 discounted at 10% for 30 years. When you discount it only for 1 year, the present value of $1 is going to be 91 cents. But when you do this for 30 years, the present value of that $1 is going to be around 6 cents. Actually, exactly 6 cents. So what it tells you is that if you have to wait longer to receive the cash, the value of that cash is going to be significantly lower than the case when you have to wait only for 1 year. So time matters a lot when it comes to finding the present value of a cash flow. Let's look at the first example. Given a 10% rate of return, what is the present value of $20,000 to be received in 5 years versus 10 years? So I really like to graphically represent the problem in a timeline. So if I draw the timeline for the first one, your N would be 5 years. Future value would be 20,000. And your IY or your discount rate would be 10%. In the second case, you have a longer time period, so N would be 10. Future value is still 20K, and IY is the same as it was before, 10%. So we want to find the present value in both of these cases. The present value in the first case would be 20,000 divided by 1.10 raised to the power of 5. And here, 20,000 raised to the power of 10. Of course, in the second case, you're going to end up with a smaller present value because you're dividing the same cash flow by a larger denominator here. Because you're doing it for 10 years, your denominator is going to be significantly larger than what you have for 5 years. So in the first case, you have 12,418. And in the second case, we have 7,710. So as I said before, because you're discounting this more, or because you received this $20 further in the future, 10 years compared to 5 years, the present value is going to be much smaller. We can do this in the financial calculator as well. So first things first, clear the time value of money function. So we have $20,000 in future value. 10% is the discount rate. And we do it first for 5 years. So the present value is 12,418.43. And then we change our N to 10 and compute the present value again. So we have 7,710. Also, we can ask Excel for help. So we are trying to calculate the present value here. So PV is rate. So rate is 10%. Number of periods for the first one is 5. And then future value is 20,000. You'll get the first number. And for the 10-year example, we have the same 10%, but this time for 10 years and same future value, you end up with 7,710. Now, let's look at the second relationship. For a given time period, the higher the interest rate, the lower the present value. Again, it makes sense because if you look at the present value formula, cash flow over 1 plus t. So for a given t, the higher the discount rate, the lower the present value, because they have an inverse relationship. There's always an inverse relationship between present values and discount rates. For example, if you can see the difference, so if their discount rate is 0, your dollar would be the same no matter when you get it. But if your discount rate is 5%, 10 years from today, your dollar, if you receive that dollar 10 years from today, it would worth only about 70 cents today. Or if you receive that dollar 10 years from today, but discounted at 20%, it would worth only 20 cents today. So the higher the discount rate, the higher the opportunity cost of waiting, and the higher the penalty that you apply to the future cash flows, right, for discounting them. Let's look at an example. Given an investment period of 10 years, so your T is the same in both cases, what is the present value of $20,000 received at the end of the period, discounted at 8% versus 4%? So now your N is the same in both cases, and your future value is the same as well. But your I is different. You're doing it at 4% and 8%. So without even calculating this, can you tell me which one is going to have a lower present value? The answer should be this. Your answer should be this. Because with a higher discount rate, you're basically punishing the future cash flows more heavily. So you end up with a lower present value. Let's do this in the financial calculator first. So first things, we clear this, and then we have $20,000 for our future value. And by the way, the order that you enter them doesn't matter in the financial calculator, but the order of inputs in the Excel matters. So just keep that in mind. So 20,000 is the future value, and your N is going to be 10 years. At the discount rate of 8%, you're going to have a present value of 9,263. And at a discount rate of 4%, the present value would be 13,511. We can look at it also in the Excel sheet. So the present value, okay, let's just do the formula. Drop down menu here. So we have PV. So the rate for the first one is 8%. And then the number of periods is going to be 10. And future value is 20,000. Sorry, for this line is 4%. So you have 13,511 for the first one, and then for the second one, I'm just going to use the formula here. So rate is 8%. Number of periods is 10. And then future value is 20,000. So you end up with, did I do it right? Yep. 9,263.87. I hope you find this video useful, and thank you for watching.